Afternoon to everybody. Uh, First, we will look at an overview of this course. Uh, the title of the course is Probability and Statistics with R, right? And I am Professor Sarath Bannayaka. I am attached to the Department of Statistics, University of Jawaharlal. We will be directly following this book for this course. The title of the book is also Advanced Statistics with Applications in R by Eugene Demidenko. Right. So mainly what this book includes is lots of statistical theory with applications, right? So it integrates the theory, computation and applications, especially the computation comes using R, right? It emphasizes the conceptual clarity over mechanical procedures. What does that mean? In most of the statistics courses taught in universities or any other place are mechanical because usually they provide several formulas and tell you what to do, and the students just follow it without understanding much what is going on, why we are doing it, and so on. What happens if we don't do it, and so on, right? So in this course, what we'll be doing is actually try to understand the underlying theory behind all the methods, and we'll try to understand what will happen. Some assumptions are not satisfied, and in that case, what can we do to answer our questions, and so on. So conceptual clarity is very important. And the book always encourages understanding what statistical methods actually do, right? The real understanding, right? When we look at, for example, the research papers out there, we see most of the authors actually don't have real statistical knowledge, right? Because most of the research papers has a component where they have analyzed some data, therefore they have used some statistical technique, right? But when we really look at them, we see lots of problems in those analysis and their interpretations. Right? For example, this book also emphasizes one important thing called p-value, right? Because in almost all statistical analysis in research papers, they carry out some kind of test of hypothesis. Right? We will come to those things later in this course. So in test of hypothesis, what many people do is somebody tell them to do okay, this carry out this test. For example, there are so many tests for different purposes, right? For example, a t-test, a chi-square test, some other test, right? So they have some data, they feed the data into the computer, and then comes the output. And in the output, there are so many things. Among them, one thing is called the p-value, right? So somebody has told them, okay, if the p-value is less than 0.05, you reject your hypothesis, otherwise you accept your null hypothesis. So many people don't know what is the theory behind that. Why we are rejecting H naught if the p-value is less than 0.05? Where does that 0.05 comes? Who chose that value? Right? Everybody is using 0.05. Right? So if the p-value in the computer is less than 0.05, they say, okay, we have enough evidence to reject H naught, and so on. Many people don't know even what the hypothesis H naught is, but they just say we reject H naught. So there are so many confusions, right? And the computer calculates this something called p-value under some assumptions, right? For all the tests developed by people, they develop those statistical tests under some assumptions, right? So p-values are also calculated under the same assumptions, right? So in your practical application, if those assumptions are not satisfied really, then even though the computer gives you a p-value, that p-value doesn't have any meaning, or maybe completely wrong meaning, right? So if you really don't know what the assumptions behind your test, then you may be just looking at the p-value and saying, okay, we reject H naught and then come to a certain conclusion, but that conclusion may be completely meaningless. Right? So therefore, it's very important to understand the concepts behind statistical methods. Right? So in this course, we will mainly focus on that kind of things to understand the ideas or logics behind the theory in statistics. Right. So actually, this book uh, concentrates on those things. Therefore, we will be concentrating on those ideas also. So, as an overview of this course, I will just tell you the objectives of this course in general, and then what is the learning approach that we will be using in this class, and then what are the expectations, outcomes that I expect from you by the end of the course, and then who is going to be, what kind of people are going to be benefited from this course, right? So let's look at each of these separately. So what are the objectives of this course? As mentioned here, we expect to develop a deep and practical understanding of probability and statistics. Right? This is a very important thing because in most of the elementary statistics courses, you learn probability and different types of statistics, but of only superficial understanding is obtained given in those cases, right? So, but that is not enough to understand or be a good statistician to interpret the results and give the correct interpretations and so on. So, you have to have a deep understanding, right, of practical things, because statistics is a practical course, right? Whenever we apply something, some statistical technique, there is a reason why we are applying it, and when we get some results, we should be able to interpret the results correctly, right? So therefore, deep practical understanding is important. And then we will be combining theory, computations in R, and real life applications. Right. So if you look at most of the courses out there in statistics, right, everybody in every discipline they learn some at least one statistic course somewhere, right? uh, Physical science students learn little bit higher type of statistics, but even medical students learn statistics, right? There are several disciplines in medical faculties, for example, they all learn statistics, right? But their levels are different, right? In most of the statistics courses, they just learn theory and some methods, right? And then how to just do the calculations and mechanically come to some decisions. And in the university level and also in the school level, the computations are still done manually, right? So actually, when we try to check the knowledge of the students within the 2 hour exam period, more than 1 hour should be allocated for the mathematical calculations, right? So only very little knowledge can be actually tested because most of the people take a lot of time for the mathematical calculations, right? But in this course, what we are going to do is we are not going to do any mathematical calculation manually. We will be doing everything using R, right? Because R is a very important uh, programming language nowadays, right? For every field, you can apply that, and R can be specially used for statistical calculations. There are so many statistical packages included in it. So we will be using R to do all the computations in our course. We will not be using any calculators in this course. One important thing here is actually this book has given a lot of data sets related to some real life applications, right? Even though we learn some theory in the class, usually we consider some uh, imaginary examples to explain those things. But when you really go to the real life and apply the statistics, you come across a lot of problems, right? So by analyzing data, real data, you will actually face that kind of problems and see how to uh, avoid or maybe come through those problems. So therefore, that will be an important thing. The one objective of this course is to learn that kind of situations, to face that kind of situation. And another objective is to avoid black box statistics by understanding the underlying assumptions. So it is the same thing that I mentioned. Actually, many people don't know what is happening, right? So somebody tells you, okay, apply a t-test and then look at the p-value. And if the p-value is less than 0.05, reject test node. So that's what they get as a instruction. So they just carry out it, put the data into the computer, and then select using a menu and carry out a t-test, and then look at the p-value. Okay, if the p-value is less than 0.05, they reject test node. And here there are so many things you have to learn, right? What is H node? How do you select your hypothesis? Right? There are usually two types of statements in hypothesis testing, right? One is called the null hypothesis, the other one is called the alternative hypothesis. Many people don't know how to select which statement should be selected as the null hypothesis, right? In exams, usually in most of the elementary exams, the lecturer or the examiner gives the H naught and H1. They give the H naught and H1. They ask to test it, right? That's what usually students learn. But in practical life, we have to decide which one out of the two statements, which one should be the null hypothesis and which one should be the alternative, according to our situation, right? So from there, you have to learn, right? There is some theory behind that, purpose behind that, and so on. Right? So you have to build your or construct your hypothesis correctly, and then select the suitable method to test that hypothesis. There are so many different tests available for the same kind of hypothesis, but your situation, you may be able to make some assumptions. If somebody else is testing the similar assumption in some other place, he may be able to make some other assumptions. He may not be able to make the same assumption that we are able to, right? So depending on what assumptions that you can make realistically, the type of test that you have to apply, you have to select the suitable test and then carry out it, and then come to the decision, right? So as I mentioned, there are so many assumptions underlying most of the statistical techniques. If you want to really be uh, really those results to be valid, those assumptions have to be satisfied, right? If you are just applying some method without checking whether those assumptions are satisfied or not, you don't know finally whether your result is valid or not, right? So therefore, it's a very important thing to know what are the assumptions underlying my method and whether those assumptions are reasonable in my situation in related to this problem. So we should be able to first test the hypothesis, the assumptions related to the method, which is not done by most of the people. Right? For example, if you look at research papers in most of the areas, they carry out something called correlation analysis. They want to test whether one variable is related to another variable. Is there some kind of relationship or whether they are independent, right? So there is something called a t-test again, right? So they carry out it, and if the p-value comes out to be less than 0.05, they decide that, okay, we reject H naught. In that case, H naught is saying that the variables are independent. So they reject that and then decide that the variables are dependent. But that p-value, usually given by the computer, is correct or valid only if certain assumptions are satisfied. For example, there is an underlying assumption that the two variables have to have something called bivariate normal distribution, right? So what is a bivariate normal distribution? You have to know that, right? And why that assumption is required for that test? How do we test whether your data are bivariate, normal, or not, right? So those are, you have to learn. Many people don't even look at any of those things. They don't know sometimes. Even some statisticians don't know, right? They just look at the p-value and then come to a decision. But good thing, the bad thing about it is actually the researcher who wrote the paper doesn't know it, and also the reviewer who reviews it also doesn't know it. They have just passed it and it's been published, right? For example, I have seen some research papers related to my university also. Some people published by my university. In one paper, I saw very something called about the p-value again, because this p-value is interpreted in completely different in a lot of situations. One person has said the p-value is the probability of rejecting H naught, which is completely wrong. Right? So the researcher, he's a statistician, but he doesn't know it. And the reviewer also doesn't know it. It has been passed and it is published. So those who look at it now take that as the definition of the p-value. Right? So that's how all these things are understood wrongly. Right? So therefore, we have to be very careful in learning statistics, especially the underlying theory and the real meaning of these things have to be understand very well. Otherwise, statistics cannot be understood well. So interpreting the results is also very important. Right? Once you have some result, you should be able to interpret it in a correct way. Right? Interpretations are wrong most of the times. Therefore, you have to be careful as well. So everything can be done correctly only if you learn the underlying theory correctly. Why we are assuming that, how to test the assumptions are correct, and so on. What happens if the assumptions are not correct? Right. So how are we going to learn these things in that way? Well, most of the type topics or whatever the method that we are going to learn will be discussed in three different levels, right? So there will be a mathematical foundation to some method that we use. For example, something called regression. There are so many different statistical methods, right? So something called regression method. There we fit a line or fit a curve or whatever for some relationship, right? So we use some methods called method of maximum likelihood, method of least squares. We use those methods, and we have to understand what is the mathematical or theoretical basis underlying those methods, and then we should know how to compute, fit the model and get the output compute. For that we will be using R, of course, right? Up to now, most of the people are using some other packages like Minitab and so on, but still they are mechanical. They don't know what. Sometimes in R, what R, the good thing about R is actually it's not like some other packages like Minitab, SPSS, and so on, which have built-in procedures, and we just put the data and run that procedure. Right? But in R, some amount of programming is always involved, and that helps you to understand actually, right? What is going on, and you can do your own programming and do whatever you want. Otherwise, packages like Minitab and SPSS can be used to do only a particular type of analysis. If we want to do some other type of analysis, we cannot do it, right? The good thing about R is we can do whatever we want. We can write down our own programs and then do whatever we want. So that's a very good thing. And the other thing is actually for graphical procedures, R produces very nice graphs than most of the other packages. So that's another advantage. So once you formulate your problem mathematically, understand the theory behind the method that you are going to use, and then do the calculations, you get the results, and then you should be able to interpret, right? So we will learn how to interpret the results in different situations. As I mentioned, uh, big emphasis will be done in this course about the clarity of reasoning rather than mechanical computations. Why we are doing this? right? That will be always discussed. If you don't understand my explanation, please don't hesitate to ask questions, right? More questions is always better, right? Because I don't understand, I don't know whether you understood or not. I cannot read your mind, right? I can answer or I can explain again only if you ask me a question, right? Otherwise, I will assume that you understood, right? That's there's no purpose of doing that, no. So you are here to learn, and I know you don't know anything, so you can ask any questions. Don't be afraid to ask questions. And if I can answer that question, I may not be able to answer some questions also. But if I can answer, I will answer. Otherwise, I will take some time and then prepare and come and answer next time also. I'm not perfect, right? Statistical conclusions must be justified, not merely reported. So whenever we report something, it has to be a practical conclusion as also justifiable conclusion. Right. So we will focus on those things when we are learning any method and reporting the results. So as I mentioned, this course is going to be somewhat different from the courses out there you will learn find in universities or in schools or some other institute. They are going to be different in different scenarios. For example, it's not going to be a collection of formulas to memorize, which is a big part in most of the other courses. You are given a lot of formulas. They just check whether you can memorize something and then put some numbers and get some answers. We are not interested in that. Uh, all the formulas and everything is in the books. We don't have to memorize anything, right? We only have to know where they are, right? As long as you know where they are, you can always use books and get them, or if you want. Otherwise, you don't have to remember any of those things. So remembering is not important, but understanding is the important thing, not remembering, right? Not a sequence of software commands. Again, commands you don't have to remember, because R, if you forget something, you can always use the built-in help facility to for you to remind yourself about that. Also nowadays, of course, you can ask ChatGPT what is the command for doing that and so on. So that's okay, because all the available resources you can use. Only thing is that you have to be able to do the thing correctly, right? Of course, when you are using ChatGPT, you have to be very careful because it gives you wrong answers most of the times. Unless you know the stuff correctly, you are going to be deceived, right? For example, I have come across a lot of situations where it gives you some very, very sloppy answers. And when I tell you, okay, you are wrong and this is the correct answer, yes, it says, oh, absolutely, you are correct, and so on, so on, so on, so on. It's learning from us rather than we are learning from it. So you have to be careful, right? So it's not a plug and play approach, like just putting the data into a computer and getting output. So you have to know everything behind it before you get the results. So statistics will be treated as a clear method for dealing with uncertainty and making careful decisions based on data. That's what statistics is, right? So how to make uh, well informed informations using the data, right? Data gives you some uncertainty always regarding different events, right? So we want to make some decisions using those uncertain data, and we should be able to not only make some decisions. One important thing is that we should be able to tell how confident we are about those results, right? Of course, in using statistics, you will never be able to say I'm 100% sure that my result is correct. That will never be able, you will not be able to do that, right? Because there is always uncertainty in data. Therefore, you cannot get 100% confidently correct results, right? But of course, if you use the correct methods, you will be able to measure how confident you can be about your result. So if that is a large value close to the 100, that means it's highly confident. You can be confident about that, right? So it's not a collection of formulas to memorize, right? We are not going to give you just some sequence of commands to memorize, right? It's not a plug and play method, but it is going to be it's going to be treated as some discipline which you can use to get meaningful answers, uh, to analyze the data and then come to decisions with known accuracy. Right. So, what are the learning outcomes? What do we expect from you? By the end of the course, generally, we expect you to be able to do these things. Choose an appropriate probabilistic model for a real problem. Right. So, usually, when you solve a problem, statistical problem, there are mainly two approaches. One approach is to approximate the real problem by an approximate problem and then try to get the exact answer for the approximate problem. Right? You change the problem little bit to make an approximate problem and then get the exact answer for the approximate problem. Or you can get an approximate answer for the real problem. Right? So those are the two main approaches that you can use. But in both cases, usually you will be using some kind of models, probability ideas. So therefore, you should be able to select which probability model or some other model is more suitable for your problem. Right? We will be learning lots of probability models, uh, uh, something called probability distributions and some other models. So you should be able to select a suitable model for your problem. Maybe several models for the same problem. Right? We will be learning something called inference, statistical inference. Right? That is the main purpose of statistics. We want to be able to make decisions about some unknown quantities or unknown phenomenon related to some populations based on a sample of data taken from those populations. So that's what we mean by statistical inference. So in the statistical inference, mainly we have to do certain things called estimation. We have to estimate certain quantities, right? Or we have to test some hypothesis regarding some unknown quantities or unknown phenomena, right? So you should be able to select suitable methods to estimate or select suitable tests to test the hypothesis and so on in given different situations. Assess evidence and communicate conclusions clearly, right? So this is a very important thing. Communicating the result effectively and correctly is very important, right? Because as a statistician, when a statistician gets a problem from a client, the client has very general words, but then the statistician converts it into a statistical problem with some statistical jargon, and then he carries out a statistical test or do some kind of estimation and so on, right? And then the answer comes in a way of a statistical term like p value or something, right? So for example, a person comes and tells you a problem, and you see that there is something that you want to test about unknown things, so you convert it to a test of hypothesis, right? So when you are converting that problem into a test of hypothesis, you input something called parameters, you define something called parameters, right? So that person doesn't know anything about parameter, but you input some parameters, and then you convert your problem into test some hypothesis regarding parameters, right? And then carry out the test, and then the conclusions comes about the parameter, but that person doesn't understand anything about parameters. So we have to be able to communicate that result that we got in terms of parameters in a way that he can understand. So that is important, right? The result has to be given at the end to the client so that he can understand. So that is important, right? Most of the people cannot do that part. So what they do is they test the hypothesis and say we reject H naught. So the client doesn't know what H naught is. What is the null hypothesis? Null hypothesis was created by us, statistician. So you have to uh, get back to his language when you are giving the results, right? Implement and validate analysis in R. So that means calculations. So all the calculations you should be able to do using R. explain results in plain language with correct interpretations. That's the same thing that I mentioned earlier. Right. So, in general, for example, in most of the problem solving, we will use this approach, right? There will be some kind of modeling most of the times, right? And then there will be some method that we apply to solve the problem and assuming that model, right? So you'll have to do some calculations for that, right? So, for example, fitting a regression model, testing a hypothesis, estimating something, and so on, and then come to the interpretation of the results, right? So, therefore, as if you want to get some, if you want to explain to somebody else what this course is going to do in general, you can just take these things as the final objectives of this course, right? We will learn statistics as a applied science because it's an applied subject, rigorous in ideas, careful in interpretation, and effective in computation. So, what do we mean by that? Uh, you will learn how to use precise definitions and clear assumptions, right? Understand why a method works, not just how to apply it, right? Why that works in this situation, and not how just to how to apply it, right? And check assumptions. It's a very important thing. So you have to know what the assumptions are before you checking, and then you have to know how to check, right? The assumptions. Justify conclusions logically. Sometimes we get answers, they are not logically acceptable sometimes, right? For example, maybe because of some mathematical calculation, or maybe because of your assumptions are wrong, and so on. So once you have an answer which is not really practically acceptable, you should be able to understand that you have made a mistake somewhere, right? At the beginning, you don't know where the mistake was, what the problem was, but at least when you look at the answer, you should see that this answer cannot be correct. Right? For just to look at it, giving a simple example in the elementary level, we learn in the class that the probability of some event is between 0 and 1. Right? So theoretically, we learn it. Right? So in the exam, we give a lot of problems to calculate probabilities of different events. Right? So some people get answers like 105 and put two lines under that and just keep it as an answer. He doesn't understand that his answer is wrong. So that means he has just learned. If I ask them to write down what are the properties of probability, they will write down, okay, probability greater than 0, probability should be between 0 and 1, all the properties will be written. But when he get an answer like probability is equal to 105, he doesn't know that his answer is wrong. So that kind of things are not acceptable, right? If similarly, for example, if you know something has to be positive, you are estimating it, but you get a negative answer. So that gives you an idea that there is something wrong. So you know your estimate has to be positive, even though you don't know the value, it has to be positive. Right? So that's what you mean by justifying. Right? The justifying the conclusions logically. Interpret results in context, not mechanically, right? Uh, without just saying, okay, because p value is less than 0.05, we reject it. No, that is mechanical, right? You have to know what it means. Why are you rejecting H naught if p value is less than 0.05, and is the p 0.05 a magic number? For example, you may have already learned some statistics where some people say, okay, if the sample size is greater than 30, everything is okay, right? 30. 30 is not a magic number, right? So you can apply something called central limit theorem in some situations when if n is larger than 30, sample size is 30, but that is not a magic number. Sometimes for you to apply that particular theorem, central limit theorem, to be valid, n may need to be more than 100. 30 is not enough, right? So if you are just applying 30 always, that is being mechanical. That is because you don't know the underlying theorem, what is really happening, right? So you learning these things are important. Understand what statistical conclusion do and do not imply. Right? For example, when you reject some H naught null hypothesis, you are not proving that it is wrong. Right? It's not a proof. It's not a mathematical proof. right? But some people, if you reject something, then you take it as a proof that it is wrong, right? So there are ideas like that. You have to really understand the meaning of your result. Avoid common misunderstandings like p-values, misinterpretation of p-values and so on, because this person has specially mentioned in where he has written why I wrote this book. One main objective of his was to discuss about these misunderstandings, especially about p-values and so on. Right. Communicate uncertainty clearly. Right. You use the probability as a measure of the uncertainty. So you have to be able to explain if you get a value, for example, probability of something is equal to zero point 0.8. What does it mean in this particular situation? You have to have some idea, right? Communicate uncertainty. Implement methods correctly in R and use simulations to explore and verify results, right? So we will be using a lot of simulations to understand the theory, right? Sometimes we have to understand what a confidence interval is, right? What a p-value is, and so on. We can do some simulations and understand the theory using simulation. So we will be doing those things also. So therefore, this course will include all of those, right? Who will be benefited by this course if they take, right? Actually, anybody, right? Anybody who needs to be able to understand the applications of statistics will be benefited, because this is going to be a long course, I think, because there are so many topics. I don't have any idea at the moment how long it will be and what Dr. Prasad has in his mind, how many chapters does he want me to complete. But if I go for the whole book, it will take a lot of time, I guess. But you will be learning most of the statistics with a good understanding by the end of the course. So generally, any person in any of these fields can benefit from this course. So therefore, let us begin to learn. So that's it as the overview.